Hey guys, welcome to lesson 3 of the True Beauty of Math, where we're now going to learn about subsets of sets. So namely, in lesson 2, we learned about sets in general, and we saw that sets were just collections of elements. And since elements are just things, any kinds of things, then sets are just collections of things, and then subsets are just exactly what they sound like. They are sub-other sets. So namely, let's look at an example of a subset of a set. So let's consider the set A, whose elements are, let's say, Kobe, mac and cheese, and the number 8. Okay? We can also consider some other set. Let's call it B. And let's say that B has the elements Kobe and mac and cheese. Now, what we notice is that every element that's in B is also in the set A. There are elements in A which are not in B, but it is definitely true that everything that's in B is also in A. Now, what we're going to do is we're going to define this to be the property of B being a subset of A. So let's just make this definition. Here's the definition. A set B is a subset of another set, A, is a subset of A, if it is the case that every element in B is also in A. So note that it says nothing about whether or not all the elements in A are also in B. In fact, this is what we mean by A being the sort of parent set of the subset B. Everything in B is in A. It doesn't have to be the case that everything in A is in B. And this is just one example of a subset B being a subset of a set A. Now, there are a couple things that we notice about this. First of all, with this definition alone, we're forced to realize that every set is a subset of itself. Namely, every element that's in A is in the set A. This is an obvious statement, and it almost seems too obvious to even give any real focus to, but it ends up being a remarkably beautiful fact, one that we're totally forced to acknowledge by our definition of what a subset is. Now, we'll see when it comes to counting the subsets of a given set that the fact that A is a subset of itself, as is B, B is a subset of itself, every element that's in B is also in B. The fact that any set is a subset of itself is an important fact that we'll need for when we count subsets of a set and various kinds of constructions that we're going to make in future lessons, like power sets and counting the elements of power sets and things like this. So it's important to understand the definition. A subset of B is a subset of A if it is the case that every element in B is in A. And then some of the logical consequences that we're forced to acknowledge simply from this definition. Once we make this definition, we're forced to acknowledge that any set is a subset of itself. There's even more about these things, as well as various subtleties with what's called the empty set and other details that I haven't gone over here, but which are in the written lesson, either linked below if you're watching this on YouTube, or just written below if you're already on the website. And for even more details, you can check out the book, The True Beauty of Math, Volume 1, where we go into all of these things in even greater detail. We give exercises and provide full solutions in the back as well. So once we've used the website, the book, and this video to get totally comfortable with subsets, we're ready to move on to lesson 4. I'll see you guys there.